What is the longest mountain range in the world? It's not the Himalayas, the Andes, or even the Rockies. It's the Mid-Atlantic Ridge, carving the Atlantic Ocean in two. Iceland sits atop the ridge. The Mid-Atlantic Ridge is where the continental plates slide apart from each other, with new material filling the gap. The Eurasian plate and North American plate are moving apart from each other at a rate of about 2.5 centimeters a year, slightly slower than the growth of your fingernails. In other places, one plate slides beneath another, destroying the landmass above it. On the other side of the world lies the Mariana Trench, the deepest point in the ocean, which was formed by one such subduction. How could we ever measure such drift of the continents? For this, satellites hanging over the Earth can help us. In 1976, NASA launched LAGEOS, the Laser Geodynamics satellite. It's massive, over 400 kilos, spherical, covered with reflectors, and completely inert, containing no electronics. A giant disco ball orbiting the Earth. From ground stations around the globe, laser pulses are sent to LAGEOS. The time it takes the laser to be reflected back is used to precisely measure where the satellite is in respect to the ground. From this data, the precise gravitational properties of the Earth can be found, that is to say, where the Earth is densest or least dense. Such data can be presented as a geoid. It is also used to measure the movements of the continents. The satellite orbits Earth at a distance of roughly 5,900 kilometers, far higher and more stable than most satellites. The ISS needs periodic boosts to keep it in orbit because it still interacts with the tenuous atmosphere at that height. In 1979, Skylab, the US's first and only fully operated space station, fell to Earth over Australia after about 6 months in space. A similar fate will befall the ISS without periodic boosts. The mission lifetime of satellites in the lowest orbits is from weeks to decades. The mission lifetime for LAGEOS, so much further from Earth, is 8 million years. In the 70s, 4 space probes were launched from Earth to explore the planets of the outer solar system. To reach these amazing distances, the probes were launched at such high velocities that they left the solar system, never to return. Humankind's first ventures beyond our home star system. On each probe was placed a capsule, a message for any future discoverer, any alien who came across it. The 2 Pioneer probes contain plaques, and the 2 Voyagers contain records, containing images and sound. It's exceedingly unlikely the probes will encounter any life form ever again. They will spend an eternity floating in the void. LAGEOS also contains a plaque. It isn't a plaque for aliens, not in the typical sense anyway. It's a plaque for the inhabitants of Earth millions of years from now, when LAGEOS deorbits or is recaptured. Even if humans continue to thrive, in 8 million years, our descendants will not be human. Evolution never stops. And 8 million years ago, our ancestors were similar to chimpanzees. We can't expect our language or method of communication will survive even a few thousand years, let alone millions. As such, just with the Pioneer plaques, the LAGEOS plaque contains only images and simple symbols and diagrams, with minimal text or language. The LAGEOS plaque is split into 4 parts. The top section shows the name and a diagram of the satellite on the left, and a series of binary numbers, incrementing from 1 to 10, using ones and zeros. Next to this, there's a diagram of the Earth orbiting the Sun, with a binary mark for 1, which can be inferred to mean 1 year. The arrow, a universally understood symbol to us today, marks the orbit of the Earth and is used to indicate time in the diagram below. The large binary number is approximately 268 million. The arrow and context indicate that the diagram is showing the Earth that many years in the past. At this point in the distant past, all continents were squashed against one another. Pangea. Continental drift had not yet pulled the separate continents apart. Animals could freely wander between Africa and South America like the mesosaur, the fossils of which were a puzzle to paleontologists of the past when the continents were thought to be fixed. The third section shows the Earth as it is today, showing when and from where LAGEOS was launched, Vandenberg, California, 1976. Although in this diagram it's year 0. The final diagram shows the Earth over 8 million years from now. LAGEOS returns and the Earth's continents have shifted. Africa is no longer attached to Eurasia, and Australasia has more land masses. Should any intelligent creature come across it, they can compare the LAGEOS maps with their own to calculate when the satellite was launched. Everything changes, even the continents. Will anyone see the diagrams on this plaque again? What will we do if tomorrow an artificial meteor brings a plaque from an undiscovered, extinct species that inhabited Earth millions of years ago? Thanks for watching.